Now let's draw a radius and start to move it through quadrant 1. Wherever we stop, we can draw a line from the end of the radius straight down to the x-axis, and we have a triangle. This will always be a right triangle with an x leg and a y leg, and the radius as the hypotenuse. If these terms are unfamiliar, go back to the geometry tutorials earlier in the series and catch up. Otherwise, let's observe that as this angle grows, the hypotenuse is always the same, as it's the radius of the circle, but the lengths of the legs change in a way that depends on the angle. When we get past the vertical, the triangle is now in quadrant 2, and as we pass the horizontal, the triangle appears in quadrant 3, and finally quadrant 4. To describe the precise relationship between these side lengths and this angle, we can use trigonometric functions. Let's forget the circle for a second and just look at a right triangle. Here are the two legs, the hypotenuse and the angle of interest, theta. From now on, we will differentiate between the two legs by calling this one the adjacent leg, because it is the leg right next to the angle, and this one will be the opposite leg, because it is directly opposite the angle. We will say that the sine of theta, which is abbreviated this way, sin, then the theta symbol, will be equal to the length of the leg opposite the angle over the length of the hypotenuse. The cosine of theta will be equal to the length of the adjacent leg over the length of the hypotenuse. And the tangent of theta will be equal to the length of the opposite leg over the length of the adjacent leg. We can remember these definitions using the mnemonic SOHCAHTOA. These letters stand for sine, opposite over hypotenuse, and then cosine, adjacent over hypotenuse, and lastly, tangent, opposite over adjacent. Say it with me one more time. SOHCAHTOA. Looking at this triangle with sides of length 3, 4, and 5, sine of theta must be 3 over 5. Cosine theta is 4 over 5, and tangent theta is 3 over 4. Now we must learn the reciprocals of these functions. Cosecant is the reciprocal of sine. If sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Secant is the reciprocal of cosine, so instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Cotangent is the reciprocal of tangent, so instead of opposite over adjacent, it's adjacent over opposite. So we definitely have to memorize SOHCAHTOA, and then we just have to memorize which functions are the reciprocals of these three, since we can just flip these ones to get the others. So let's take this triangle with sides of 5, 12, and 13 and evaluate all 6 trigonometric functions for this angle. We can place all the letters first to represent the sides involved in each calculation. Then we fill in the respective numbers. See that there isn't really any reducing to be done, so these are the 6 values we end up with. So now that we know how to evaluate these functions, let's look at 2 special triangles that will come up a lot. These are the 30, 60, 90 triangle and the 45, 45, 90 triangle. Let's find the sine, cosine, and tangent for these 3 angles. First, for 30 degrees. As we recall from geometry, if the shorter leg of this triangle has a length of 1, the other sides must be root 3 and 2. Therefore, the sine of 30 is 1/2. The cosine of 30 is root 3 over 2, and the tangent of 30 is 1 over root 3. But since we don't like roots in the denominators, we multiply by root 3 over root 3, which gives us root 3 over 3. We can use the same triangle to evaluate the same functions for the 60-degree angle. Sine of 60 is root 3 over 2. Cosine of 60 is 1/2. And tangent of 60 is root 3 over 1, or simply root 3. Now let's do the same for the 45-degree angle in this other special triangle. As we recall, if one leg of this triangle is equal to 1, the other sides must be 1 and root 2. So the sine of 45 is 1 over root 2, but we multiply by root 2 over root 2 to get root 2 over 2. And the cosine of 45 will give us the same value since the two legs have the same length. Then the tangent of 45 will be 1 over 1, or simply 1. These triangles will come up again and again, so these values of sine and cosine will be very